Since time immemorial, humanity has looked at the starry sky with wonder and curiosity. What lies beyond our small planet? Are we alone in this vast universe? Each star, each galaxy seems to whisper secrets that we long to uncover. Throughout history, we have posed questions that challenge our understanding. Why is the universe so immense and complex? What mysteries lie hidden in the space around us? As science advances, new enigmas arise that invite us to reflect. Human curiosity is insatiable. We seek answers that help us understand our place in the cosmos. Yet, despite our efforts, there are more questions than answers. If the universe is so vast, why have we not found signs of life on other worlds? What is dark energy that seems to play with the fate of the cosmos? And do wormholes exist that would allow us to travel through time and space? Let us think about the immensity of the universe with trillions of stars and billions of galaxies. It is hard not to wonder if there are other sentient beings also observing the sky. However, so far we have had no conclusive evidence of their existence. So are we alone in this immense darkness, or perhaps life is out there? Hidden in corners we have yet to explore, dark energy is another one of those enigmas that leaves us perplexed. This mysterious force is not only present but is accelerating the expansion of the universe. What exactly is it? How can something we do not see influence the very structure of the cosmos? These are questions that scientists are still trying to answer, leading us to question the nature of our reality. And then there are wormholes, those hypothetical tunnels that could connect distant points in the universe. Could they be the key to intergalactic travel? Imagine being able to cross enormous distances in the blink of an eye. But are they just a fantasy of science fiction, or is there some truth to these theories? Moreover, there are places in the universe that seem to be empty, like the cold void of Bootes, where the scarcity of galaxies makes us question the very nature of matter and energy. What does this mean for our understanding of the cosmos? Do we really know the history of the universe, or are there chapters left for us to discover? The geometry of the universe is another fascinating mystery. Is it flat, curved, or does it have a shape that escapes our imagination? Everything seems to indicate that the answer has profound implications for how we understand time and space, and amidst all this are pulsars. Those cosmic beacons that spin at incredible speeds. They emit radiation in a way that makes us think about how we perceive time and space on a grand scale. Dark matter, for its part, is an essential component of the universe that we cannot see, but we know is there, holding galaxies together. What is this invisible substance that makes up most of the cosmos? And why is it so crucial for the structure of the universe in this vast sea of questions? We also find the arrow of time, a phenomenon that seems to flow in one direction. Why can't we go back in time? And speaking of time, the singularity of a black hole is a place where the laws of physics seem to fade away. What lies at the heart of these mysterious objects? Finally, we cannot overlook the concept of the multiverse. Is it possible that our universe is just one of many, perhaps infinite? And as we ponder this, cosmic rays, those enigmatic messengers from deep space, reach us without warning, challenging our understanding of physics. Each of these mysteries of the universe invites us to keep exploring, to question, and to marvel. In the end, the search for answers is what drives us to move forward, and each discovery brings us a little closer to understanding our place in this vast and intriguing cosmos. The vastness of the universe is an enigma that fills us with wonder. At the heart of this enigma lies a question that has intrigued scientists, philosophers, and curious minds throughout history. Where is everybody? If the universe is so immense and filled with stars and planets, why have we not yet found extraterrestrial life? This question is known as the Fermi paradox, and although it sounds simple, its implications are profound and perplexing. Is it possible that in an infinite sea of possibilities we are completely alone? The Fermi paradox invites us to reflect on the vast number of stars that exist in our galaxy, the Milky Way, which is estimated to be over 100 billion. Each of these stars could, on average, have at least one planet orbiting around it. With so many potentially habitable worlds, the idea that there is no life seems almost absurd. However, so far we have not found conclusive evidence of extraterrestrial civilizations. What could be preventing us from discovering this life? There are several theories that attempt to answer this question. One of them is that perhaps life is extremely rare. Although the conditions for life seem to be common, the complexity necessary for intelligent life to emerge could be exceptionally difficult to achieve. Is it possible that life as we know it is the result of a series of highly improbable events? Another possibility is that advanced civilizations tend to self-destruct before they can establish contact with others. As technology advances, so do the risks. Wars, ecological disasters, and other threats could be the factors that limit the lifespan of a civilization. Could it be that we have reached a point where our own existence is so fragile that contact with other civilizations becomes an illusion? Distance also plays a crucial role in the Fermi paradox. The vast separations between stars make communication and travel between them extremely complicated. Is it possible that there is life out there? But it is so far away that our paths will never cross. The immensity of space may be an insurmountable obstacle even for technologically advanced civilizations. Scientists have also proposed that perhaps we are not searching in the right place or in the right way. The search for extraterrestrial intelligence, known as SETI, has been trying to detect radio signals from other civilizations. However, what if those civilizations do not use the same technology as we do? They might be communicating in ways we do not yet understand. The idea that some living beings might be in a state of development very different from ours is also intriguing. Could it be that we are looking for something that is not comparable to us? Perhaps there are forms of life that do not require carbon or that do not need water like we do. The diversity of life, even on our own planet, is astonishing. Who can say what forms life might take on other worlds? As we explore space, we discover new planets and moons that could harbor life. Some, like Europa, a moon of Jupiter, seem to have oceans beneath their surface. Others, like Mars, have shown signs of water in the past. Could these be the keys to unraveling the Fermi paradox? Are we one step away from finding signs of life in our own solar system? However, the Fermi paradox can also be a call for introspection. If we are the only ones in the universe, what does that mean for us? Cosmic loneliness could be a reminder of the importance of taking care of our planet and the responsibility we have as a species. The search for life is not just the search for others, but also the search for ourselves. Ultimately, the Fermi paradox invites us to keep asking and exploring. Each discovery in astronomy and astrobiology brings us a little closer to answering this intriguing question. Although we have not yet found definitive answers, the mere act of questioning pushes us to keep moving forward, to keep searching. In this vast universe, each star is a beacon reminding us that there is so much more to discover. Human curiosity is a powerful force, capable of pushing us to the limits of knowledge. Perhaps one day, when we look up at the starry sky, we will not only see distant lights, but also signs of life, echoes of the ingenuity and creativity of other civilizations. The Fermi paradox is a reminder that, although we may not have all the answers, the search is what truly matters. So let us continue to look to the sky, for each star could be a new chapter in the story of the universe. And perhaps, just perhaps, one day we will find the answer to the question that has haunted us for so long. Where is everybody? Perhaps they are out there, waiting to be discovered. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Dark energy is one of the great enigmas of the universe. Imagine a vast space constantly expanding, driven by a force that we cannot see or touch. But what is dark energy really? Despite occupying approximately 73% of the universe, it remains a mystery to scientists. How is it possible that something so omnipresent is so elusive? The first question that arises is, why can't we detect it? Unlike the matter we know, which interacts with light and other forms of energy, Dark energy does not seem to have any interaction with matter. It does not emit light, does not reflect light, and, in essence, appears to be transparent. This makes its detection and study extremely complicated. Could it be that dark energy is a form of energy completely different from anything we know? It has been proposed that dark energy is responsible for the acceleration of the universe's expansion, but how can an invisible force exert such influence? When we observe galaxies, they seem to be moving away from each other. In the past, it was thought that this expansion was slowing down due to the gravity of matter. However, in 1998, astronomers discovered that, in fact, the expansion is accelerating. Once again, dark energy appears as the culprit, but what drives it? There are various theories to explain the nature of dark energy. Some scientists suggest that it could be a cosmological constant, a term that Albert Einstein introduced in his equations of general relativity. However, others propose that it could be a dynamic phenomenon changing with time and space. Which of these theories is correct? So far, there is no definitive answer. Another intriguing idea is that dark energy could be related to the energy of quantum vacuum. In quantum mechanics, the vacuum is not an empty space, but a place where particles constantly appear and disappear. But if the vacuum has energy, could this energy be what we know as dark energy? The complexity of this connection suggests that we are still far from fully understanding the universe. The difficulty in investigating dark energy is the reason it remains a mystery. The tools that scientists use to study the cosmos, such as telescopes and observatories, are limited by the light and matter they can observe. Dark energy, by not interacting with light, escapes these tools. But what if we could develop new methods to detect it? The concept of dark energy also raises profound philosophical questions. What does it mean for our understanding of the universe if there is a force that we cannot see or understand? This leads us to question our perception of reality and the place we occupy in this vast cosmos. Are we prepared to accept that there are aspects of the universe that will always be beyond our understanding? One fascinating aspect is how dark energy challenges our intuition about the universe. We often think of gravity as a dominant force that keeps galaxies together. However, dark energy seems to be winning the battle, pushing the universe toward unlimited expansion. Could it be that gravity, the force we consider fundamental, is just one of the many forces that govern the cosmos? As scientists continue to explore the universe, the search for dark energy also progresses. Experiments like the Vera C. Rubin Observatory and the James Webb Space Telescope are designed to help unravel this mystery. These instruments could provide new clues about the nature of dark energy and its impact on the history of the universe. But will it be enough to solve this enigma? As we move into the future, dark energy will continue to be a focal point in the scientific community. Every discovery related to this mysterious force could change our understanding of the universe, challenging what we thought we knew. Are we ready to face the possibility that there are still many secrets to uncover in the vast cosmos? In conclusion, dark energy represents one of the greatest challenges in modern science. It invites us to question what we know about the universe and reminds us that there are forces operating beyond our current understanding. When will we unveil the secrets of dark energy? The answer may be closer than we imagine, or we may still need much more time to unravel this mystery. What is certain is that human curiosity will lead us to continue exploring, questioning, and marveling at the immensity of the universe. Wormholes are one of the most fascinating and enigmatic concepts in the universe. But what exactly are they? Imagine a tunnel that connects two distant points in space-time. This tunnel could make intergalactic travel as simple as a walk in the park. But do these wormholes really exist, or are they just an idea taken from science fiction? The theory behind wormholes is based on Einstein's general relativity, which tells us that space and time are intertwined in a kind of fabric. If we could bend or deform this fabric, we could create a shorter path between two places. But what implications would this have for intergalactic travel? We could explore the cosmos in a way that today we can only dream of. However, there is a great mystery that holds us back. So far, we have not found concrete evidence that these tunnels exist. Can you imagine crossing a wormhole? The idea is tempting, but also terrifying. Some scientists suggest that if we ever manage to traverse one, we might face unexpected consequences. What if we emerge in a different place in space, at a different time? The time travel paradox becomes even more complicated. Would it be possible to alter past events? The theories are numerous, but the answers remain elusive. Let's talk about how a wormhole might work. These could be formed by exotic matter, a substance that would have very different properties from the matter we know. But here comes the intriguing question: what exactly is exotic matter? It is not only a complicated concept, but to date we have not been able to create it or find it in nature. Could it be hidden in the darkest corners of the universe? Time is another crucial factor. If we could travel through a wormhole, could we do so at any moment? Some theorists suggest that we could jump not only through space but also through time, but if we did, would we be able to return, or would we be trapped in a past or future era? The idea of time travel adds a level of complexity that could change our perception of reality itself. Moreover, we must consider the stability of these wormholes. Some scientists believe that even if we could create one, it might collapse instantly. What sense would it make to open a door that closes so quickly that we couldn't pass through it? Stability is key. And most current theories suggest that wormholes would be extremely unstable. Science has yet to find a clear path to prove the existence of wormholes. However, this does not stop human curiosity from continuing to investigate. Why is it so important for us to understand these mysteries? The answer lies in our desire to explore, to go beyond what we know, and to challenge the limits of our imagination. As we advance in our understanding of the universe, the possibility that these cosmic tunnels exist becomes a goal. If we manage to prove their existence, we would open a new chapter in space exploration. We could visit other galaxies, discover new worlds, and perhaps even find forms of life we never would have imagined. However, like many aspects of science, the search for wormholes raises ethical questions. If we had the ability to travel through time or space, should we do it? The implications are enormous. Would we alter the course of history? Would we become the architects of our own destiny? Or would we fall into unpredictable chaos? It is fascinating to think that in some corner of the universe, these doors to the unknown might exist. Science is advancing by leaps and bounds, and each new discovery brings us closer to answering questions that seem impossible. The search for wormholes reminds us that curiosity is the spark that ignites the fire of human knowledge. In conclusion, wormholes are more than a science fiction topic. They are a symbol of our desire to explore the unknown. Although they remain a mystery, the possibility of their existence invites us to keep dreaming, investigating and questioning our understanding of the cosmos. Who knows what wonders we might discover if we dare to look beyond the stars? There are vast regions of the universe that are practically incomprehensible to us. One of them is the cold void of Bootes, a place so strange that it seems to challenge our understanding of the cosmos. But what makes this area so special? First of all, it is located in the constellation of Bootes, which is visible in the northern hemisphere. However, what is truly surprising is that unlike other areas of the sky that are filled with galaxies, this void is one of the most desolate regions we have found. Have you ever wondered why there is such an empty place in a universe that is seemingly full of matter? What makes Bootes unsettling is that in an area of approximately 102 million light-years in diameter, it contains very few galaxies. In fact, there is a significantly lower amount than what would be expected. Something in this void invites us to question how matter is distributed in the universe and what forces might be influencing it. Imagine you are in a vast ocean surrounded by water on all sides, and suddenly you find yourself on a deserted island. That feeling of isolation is similar to what we experience in the cold void of Bootes. But what caused this cosmic loneliness? One of the most intriguing theories suggests that these empty regions could be the result of gravity. Galaxies, by attracting matter around them, may have left this space devoid of it. And when we talk about gravity, we cannot help but wonder, how does matter behave in such extreme places? The answer lies in cosmology, the science that studies the universe as a whole. In the case of Bootes, some scientists believe that dark matter could be playing a crucial role in the formation of voids. And what is dark matter, you may ask? It is a form of matter that we cannot see, but we know exists due to its gravitational effects. Without it, the universe would be a very different place. The existence of these voids also raises a fascinating question. What does it mean for the structure of the universe as a whole? Some researchers suggest that the cold void of Bootes could be a window into understanding how galaxies and matter are organized in the cosmos. Imagining that our universe is not just a sea of galaxies but also has large expanses of emptiness is a concept that changes the way we think about space. However, the cold void of Bootes is not the only empty place in the universe. There are other smaller voids, but Bootes is the largest known so far. This leads us to wonder, are there other even emptier regions that we have not discovered? The exploration of the cosmos is ongoing, and each new space mission we launch could reveal more about these mysteries. We might think that a void is simply a place without life, but in reality, these spaces can be full of secrets waiting to be uncovered. What kinds of phenomena occur in such inhospitable places? Research in these voids can reveal more about the nature of the universe, from the formation of galaxies to the evolution of matter. Each new finding leads us to question the limits of our understanding. Moreover, the cold void of Bootes could be related to other theories about the universe, such as accelerated expansion, which tells us that the cosmos is expanding at an ever-increasing rate. Could this void be an indication of cosmic forces that we do not yet fully understand? Science drives us to continue exploring and questioning, and the void of Bootes is a reminder that there is still much to discover. As we look up at the sky and contemplate the vast universe, it is easy to get lost in the beauty of stars and galaxies, but we often forget that there are also vast stretches of silence and solitude. The existence of these voids invites us to reflect on our own existence and our place in the cosmos. What does it mean to be part of a universe where there is so much empty space? It is a question that leads us to explore not only the cosmos, but also our own lives. In the search for answers, each discovery leaves us with more questions. The cold void of Bootes is an enigma that encourages us to keep investigating, to keep looking at the sky with curiosity and wonder. The science of space is an endless journey, and each new finding in places like Bootes brings us a little closer to the truth about the universe. Perhaps one day we will understand why these voids exist and what secrets they hold. Exploring these corners of space is not only a scientific endeavor, but also a philosophical journey. It leads us to question our own reality, to reflect on what it means to be alive in such a vast and often incomprehensible universe. Ultimately, the cold void of Bootes is a reminder of the wonder and mystery that surrounds us, and that there is always something new to discover in this vast universe. So the next time you look up at the night sky, remember that you are not only observing stars and galaxies, but also voids that could hold the answers to some of humanity's deepest questions. Human curiosity knows no bounds, and the cold void of Bootes is just one of the many mysteries waiting for us in the universe. Have you ever wondered what the shape of the universe really is? The geometry of the cosmos is an enigma that has fascinated scientists and thinkers for generations. But what does it really mean for the universe to be flat, curved, or have an even stranger shape? Imagine you are looking at a map of the Earth. In it, we can see how distances and shapes are represented on a flat surface. But what happens when we take that concept to a much larger scale, to the vastness of the universe? The first question that arises is, how do we measure the geometry of something so immense? Astronomers use the light from distant galaxies as if they were markers in a cosmic game of hide and seek. By observing how light bends when it passes near massive objects like black holes or galaxies, scientists can deduce whether the universe has a flat, spherical, or saddle-shaped structure. But why is this information so important? The answer lies in how matter and energy are distributed throughout the cosmos. If the universe is flat, it implies that the sum of energies on a large scale is balanced, but if it is curved, it could mean that there is more matter than we can see, which could lead to a very different ultimate fate for the universe than we imagine. Have you ever wondered if the shape of the universe influences how life develops? Human curiosity drives us to explore these questions, and each answer opens the door to new uncertainties. Mathematical models play a crucial role in this quest. We use complex equations to describe the curvature of space-time, but surprisingly, most of us do not need to be mathematicians to understand the concept. Think of the surface of a sphere like the Earth. On it, the straight lines we draw appear to curve, but on a much larger scale, those curvatures can have profound implications for the structure of the universe. Some scientists suggest that our universe could be a type of bubble within an infinite ocean of other universes. If that is true, what would the geometry of those other universes look like? The idea of a multiverse challenges our understanding of reality. If there are multiple universes, each could have its own geometry, its own way of existing. This leads us to the question, are we really unique, or are we just one of many? The expansion of the universe also influences its geometry. Since the Big Bang, the cosmos has been constantly expanding. But what does this mean for its shape? As space expands, galaxies move away from each other. This phenomenon can be imagined as a dance floor at a party, where each group of friends moves apart as the music gets louder. However, could the expansion be a clue about the shape of the universe? Some scientists suggest that the speed of that expansion could also indicate a flat universe. In the search for answers, state-of-the-art telescopes are exploring the cosmos in wavelengths invisible to the human eye. By observing the cosmic microwave background, scientists can map the structure of the universe and look for patterns that help us unravel its geometry. But what if we found that the universe is actually stranger than we ever imagined? The question of whether the universe is flat or curved is not just academic. It has consequences for our understanding of gravity, light, and existence itself. If the geometry is different, that could change our perspective on how the fundamental forces of nature interact. What if, in a universe of strange geometry, the laws of physics we know do not apply in the same way? The mysteries of universal geometry also lead us to reflect on our place in the cosmos. Are we alone in a flat and predictable universe, or are we part of a vast landscape of shapes and dimensions that challenge our understanding? The search for the geometry of the universe is ultimately a journey towards self-knowledge. Each discovery in this field helps us understand not only the universe but also ourselves. As we continue to explore and question, we get a little closer to the answers. What is the shape of the universe? Perhaps we will never know for sure, but the journey toward that knowledge is as fascinating as the universe itself. With each question we ask, we open new doors to curiosity and wonder. The story of the geometry of the universe is a constantly evolving tale full of unexpected twists and astonishing discoveries. So as we keep looking up at the sky, let us remember that every star, every galaxy, every corner of the cosmos has a story to tell, and we are here to listen. What mysteries still await us in this immense and wonderful quest? Pulsars are some of the most fascinating stars in the universe, but what exactly are they? These cosmic objects are neutron stars, extremely dense remnants of supernova explosions. Imagine a star that has exhausted its fuel, collapsing under its own gravity. What remains is an incredibly compact sphere, with such high density that a teaspoon of its material could weigh more than all of humanity. But the most intriguing aspect of pulsars is not just their density, but how they behave. Why do they spin so fast? When a star collapses, its angular momentum is conserved. This means that as it shrinks in size, it begins to spin faster, like a figure skater who increases their speed by pulling their arms closer to their body. Some pulsars rotate hundreds of times per second. Imagine an object rotating so quickly that it appears as a cosmic beacon emitting pulses of radiation, and those pulses are what make them recognizable. How are these pulses detected? Using radio telescopes, scientists can capture the radio waves they emit. When a pulsar spins, its radiation is emitted in a beam. If the beam points toward Earth, we detect it as a regular pulse, similar to a lighthouse that rotates and briefly illuminates us. Isn't it amazing to think that these flashes of light are traveling through space, crossing light years just to reach our telescopes? But what lies behind these pulses? The radiation emitted by pulsars comes from their intense magnetosphere. As they spin, the magnetic fields intensify and accelerate charged particles, which are expelled in opposite directions. This activity generates radiation that manifests in different wavelengths, from radio to X-rays. And here arises another question. What other cosmic phenomena could be related to these stars? An intriguing aspect of pulsars is their usefulness for science. Their regularity makes them valuable tools for measuring distances in the universe. Have you ever thought about how astronomers can calculate the distance to other celestial objects? Pulsars act as cosmic clocks, allowing scientists to measure time accurately. This opens up a range of possibilities for better understanding the structure of the universe. Sometimes pulsars can even form binary systems with other stars. When this occurs, the pulsar can siphon matter from its companion, creating a spectacular phenomenon known as an X-ray pulsar. Can you imagine what it's like to observe a pulsar devouring the material from another star? This process is not only amazing to see, but it can also lead to cataclysmic explosions that teach us about the evolution of stars. But the story of pulsars doesn't end there. In 1974, two British scientists, Jocelyn Bell Burnell and Anthony Hewish, made a surprising discovery. They found a pulsar that emitted regular signals, and at first they thought they might have found signals from extraterrestrial life. This finding was so shocking that they were referred to as the Little Green Men. Can you imagine the excitement of thinking you had found life elsewhere in the universe? Pulsars have also revealed information about Einstein's general relativity. By studying how gravity affects their light, scientists have been able to test fundamental theories about space and time. Who would have thought that these little stars could help us better understand the laws that govern the cosmos? However, pulsars still hold secrets. Astronomers have discovered that some pulsars exhibit strange behaviors. For example, there are pulsars that seem to slow down, something one wouldn't expect from such a dense and powerful object. What could be happening inside these stars to cause such changes? This mystery remains a subject of research. And let's talk about millisecond pulsars. These are pulsars that spin extremely fast, up to 1,000 times per second. Their discovery has led to new questions about how they form and evolve. What cosmic processes allow a neutron star to increase its rotation speed in such a way? Exploring these questions is key to understanding not only pulsars but also stellar evolution in general. Pulsars are also a fertile ground for research on dark matter. The way they interact with their environment could offer clues about this mysterious substance that makes up much of the universe. Could these cosmic beacons help us unravel the mystery of dark matter? The answer could change our understanding of the cosmos. Each new discovery about pulsars gives us a new perspective on our place in the universe. It reminds us that there is so much to learn and explore. These fascinating objects not only illuminate the cosmos, but also our innate curiosity for the unknown. As we continue to observe and study, each pulse brings us a little closer to unveiling the secrets of the universe. What other mysteries will these beacons reveal in the vast ocean of space? The search for answers has only just begun. What really composes the universe we inhabit? Although it seems like a place full of stars, planets, and galaxies, there is a great secret hidden in the darkness: dark matter. Why is it so mysterious and, above all, so important for understanding how the cosmos works? Dark matter is a substance we cannot see, but we know it is there due to its influence on gravity. How is it possible that something that does not emit light or any other form of radiation is so essential for holding galaxies together? Imagine a huge cosmic dance where stars and galaxies spin in an elegant dance, but curiously it seems there is an invisible conductor guiding every step. This conductor is dark matter. How do we know it exists? Over the decades, astronomers have observed the movement of galaxies and how they cluster. Surprisingly, the stars in galaxies rotate at much faster speeds than they should if we only considered visible matter. How is it possible that they do not collapse? The answer seems to come from this enigmatic matter that we cannot see but that has considerable weight. Without it, galaxies would simply fall apart. But what exactly is dark matter? Although we cannot detect it directly, scientists have proposed several theories. Some say it could be composed of exotic particles that we have never observed before. Other theories suggest it could be a form of modified gravity. However, the mystery persists. Why, despite all our technological advances, have we still not been able to identify this substance? One fascinating aspect of dark matter is its abundance. It is estimated that around 95% of the universe is composed of dark matter and dark energy, while only 5% is normal matter, the kind we can see and touch. What does this mean for our understanding of the universe? It raises profound questions about what we consider real and what might be hidden in plain sight. Scientists have conducted numerous experiments and observations to try to unravel this mystery. One of the most intriguing is the direct detection experiment, where they attempt to trap these dark matter particles in underground laboratories. But so far, these attempts have been in vain. What could be preventing us from making this monumental discovery? Another avenue of research is through the observation of cosmic phenomena such as gravitational lensing. This effect occurs when the light from a distant object bends around a massive object like a galaxy due to gravity. Through this phenomenon, astronomers can infer the amount of dark matter present in the galaxy, acting as a lens. But what else can be learned from these observations? As telescopes become more powerful, our ability to study the universe expands. Imagine being able to observe distant clusters of galaxies and detect the footprint of dark matter. However, each discovery brings new questions. Does dark matter behave the same way everywhere in the universe? Could there be different types of dark matter? The search for dark matter also leads us to consider the role it might play in the origin of the universe. By understanding how this substance is distributed in space, we could gain clues about how the first cosmic structures formed. Could it be that dark matter is a key to unveiling the secrets of the Big Bang? The mystery of dark matter also invites us to think about the future. If we finally manage to detect it and understand its nature, it could revolutionize our view of the cosmos. What implications would this have for life on other planets? Could there be a relationship between dark matter and dark energy, the other great unknown of the universe? Dark matter is not only fascinating from a scientific point of view, but it also invites us to reflect on our own existence. If only a small fraction of the universe is composed of visible matter, what does this mean for our understanding of reality? Perhaps what we consider the whole is just a glimpse into a vast ocean of the unknown. So as we look up at the starry sky, let us remember that what we see is just a part of the story. Dark matter is there, weaving the fabric of the universe, waiting to be discovered. Who knows what secrets it will reveal to us in the future? Human curiosity has led us to explore the unknown, and dark matter is just one of the many mysteries that invite us to keep inquiring. Are we ready to face what could change our understanding of the universe forever? The arrow of time is a fascinating concept that invites us to question how we perceive the flow of our existence. Why does time seem to move in only one direction and not the other? If we observe the universe, it is full of transformations. Stars are born, shine, and eventually die, while living beings grow, age, and disappear. However, why can't we reverse those processes and see a star extinguish and then shine again? Imagine a simple scene. A coffee cup that falls to the floor and shatters into 1,000 pieces. It is an event that we have all witnessed, but have you ever seen a broken cup come back together and stand up by itself? The answer is a resounding no. Nature and experience teach us that there is a direction in which things happen. This direction, known as the arrow of time, is related to the second law of thermodynamics, which states that the entropy or disorder of a closed system always tends to increase. But what does this really mean for our understanding of time? Entropy is an essential concept for understanding why time flows forward. In simple terms, the universe tends to move towards states of greater disorder. When a cup breaks, the arrangement of the fragments is more disordered than when it was intact. But what would happen if we could reverse the disorder and reassemble those fragments? In the world of physics, this seems unlikely, and that is one of the keys that underpins our perception of time. Another intriguing question is the relationship between time and space. Could it be that time and space are two sides of the same coin? Some theories suggest that time is not a straight line, but rather another dimension that intertwines with the three spatial dimensions. So could we think of time as a fabric that stretches across the universe, where each event is located at a specific point? The arrow of time also raises questions about the past, present, and future. Why do we remember the past and not the future? If time is a dimension in which all events are present, why can't we travel to the future as we do when recalling the past? This curiosity leads us to wonder if there is a way to experience time differently, as if we could step out of our timeline and see the bigger picture. Scientists have explored the possibility that time is more flexible than we believe. What if time is not a constant and can be altered under certain conditions? Some studies suggest that near a black hole, time behaves strangely, dilating and contracting. This leads us to wonder if there are places in the universe where the rules of time break down, allowing the past and future to intertwine in ways we do not yet understand. But what about the human perception of time? We all know that at certain times time seems to fly, while at others it feels endless. Why do we experience this? The answer may be related to our attention and emotions. When we are happy, time seems to pass quickly, while in moments of suffering, each second can feel like an eternity. Thus, time is not only a quantitative measure, but also a qualitative experience. The arrow of time also has implications in cosmology. What future awaits the universe? If time continues its course, will it expand forever or eventually collapse? The way we understand the arrow of time may influence our view of the ultimate fate of the cosmos. Some theories suggest that, in the distant future, the universe could reach a state of equilibrium where time and space behave in ways we cannot imagine. Throughout history, philosophers and scientists have debated the nature of time. From Aristotle to Einstein, theories have evolved, but the fundamental question remains unanswered. Is time an illusion, or is it a tangible reality that is part of our universe? Perhaps the answer to this question lies beyond our current understanding. In the quest for answers, human curiosity never stops. Each discovery in modern physics leads us to new questions about the nature of time. Research on the arrow of time may open doors to new theories that change our perception of reality. Are we ready to accept that time may not be what we think it is? Finally, the arrow of time invites us to reflect on our own existence. Every passing second is a reminder that we are on a journey in which every moment counts. Learning about the arrow of time not only helps us understand the universe, but also offers us a perspective on how we live our lives. In a world full of mysteries, perhaps the greatest lesson is that time is a gift, and how we use it may be the true enigma we must solve. What happens at the center of a black hole? For many, this question may seem like a mere whim of curiosity, but in reality, it is a puzzle that challenges our understanding of physics and the nature of the universe. At the heart of a black hole lies a point known as a singularity. But what does this word really mean? The singularity is a place where the laws we know break down. Imagine a place where gravity is so intense that there is no way to escape, not even for light, making black holes true cosmic monsters. How does a singularity form? It all begins with a massive star that, at the end of its life, collapses under its own gravity. This collapse generates infinite density at a tiny point. creating the singularity. However, here arises a fascinating question. What happens to the information that falls into a black hole? According to Einstein's theory of relativity, information cannot be lost. But inside the black hole, it seems to vanish. This dilemma has led to passionate debates among scientists and philosophers. But why is it so difficult to study singularities? The answer is simple. We cannot observe what is inside a black hole. Everything that approaches its boundary, the event horizon, is swallowed and remains out of our reach. However, the effects of black holes can be felt in their surroundings. For example, stars that orbit a black hole reveal its presence through the way they move, as if they are dancing around an invisible titan. So what about the physics that breaks down at the singularity? This is where quantum mechanics comes into play, this branch of physics which describes the behavior of subatomic particles, and general relativity, which describes gravity on a large scale, do not get along in this context. At the singularity, the rules governing the quantum world and the relativistic world clash, resulting in a mystery that we have yet to unravel. What implications does this have for our understanding of the universe? Some scientists suggest that a new theory, combining relativity and quantum mechanics, could be the key to solving this enigma. But will it be possible to create a unified theory that explains all the phenomena of the cosmos? The search for a theory of everything is one of the greatest challenges of modern physics. As we explore more about black holes, we find that they are not just insatiable consumers of matter, but they can also be generators of energy. Some theorists suggest that they could emit radiation, known as Hawking radiation, implying that even black holes are not completely eternal. This discovery has revolutionized our way of thinking about these objects, presenting them as more dynamic entities than previously thought. And what about supermassive black holes? At the center of many galaxies, including our Milky Way, lie these giants that can be millions or even billions of times more massive than our Sun. How do these monsters form and grow? We still do not have definitive answers, but their existence raises profound questions about the evolution of the cosmos and the formation of galactic structures. Reflecting on these enigmas, it is inevitable to wonder, what role do black holes play in the fate of the universe? As the cosmos continues to expand, these titans could play a crucial role in its future. Could black holes be the key to understanding the ultimate fate of the universe? Some scientists suggest that they could be the catalysts for a new phase of cosmic evolution. The mystery of the singularity also leads us to consider time itself. What happens to time inside a black hole? Theories suggest that time could stop at the singularity, prompting a deep reflection on our perception of time and its relationship with gravity. This idea challenges our understanding of temporality and leads us to question whether time is an illusion. In a more philosophical sense, black holes and their singularities invite us to reflect on the limits of our knowledge. As we delve deeper into the realms of space and physics, we find that there are more questions than answers, and that each discovery leads us to new uncertainties. Will we ever be able to unravel the secrets of the singularity, or will these mysteries always remain beyond our reach? Ultimately, the quest to understand black holes and their singularities symbolizes humanity's eternal curiosity. It reminds us that, although we have made significant strides in our knowledge, the universe remains a vast ocean of mysteries to explore. Every question we answer opens the door to new inquiries, and it is this fascination with the unknown that drives us to continue probing the secrets of the cosmos. And you, how far are you willing to go in the search for answers about the universe and its enigmas? What if I told you there is a number that could change our understanding of the universe? This number is known as the cosmological constant, and although many may not have heard of it, it plays a crucial role in the expansion of the cosmos. But what exactly is the cosmological constant? Why is it so important? And above all, why does it perplex scientists? To understand it, we first need to grasp a bit about the universe we live in. For a long time, astronomers have observed that the universe is not only expanding, but that this expansion is accelerating. As we look up at the sky, we realize that galaxies are not just moving away from each other. They are doing so at an increasingly rapid pace. However, what mysterious force is behind this phenomenon? This is where the cosmological constant comes into play. Originally proposed by Albert Einstein in 1917, it was thought to be a kind of repulsor that counteracted gravity. Einstein introduced it into his equations of general relativity to keep the universe static, but when it was discovered that the universe was actually expanding, he discarded it, referring to it as his greatest mistake. However, decades later, the cosmological constant resurfaced in the scientific arena. Imagine the cosmological constant as a kind of dark energy that fills all of space. But what is dark energy? Essentially, it is a mysterious force that drives the acceleration of the universe's expansion. Surprisingly, it is estimated that about 70% of the universe is composed of this dark energy. But here's the catch. We do not know exactly what it is or how it works. So why is it so perplexing? Because despite scientists formulating theories and making observations, the nature of dark energy and the cosmological constant remains an enigma. Some theories suggest it could be a type of quantum field that permeates space, while others propose that there may be variations in gravity on cosmological scales. But how can we test these theories? As telescopes become more powerful and space missions advance, astronomers continue to investigate. But even with all our technology, the cosmological constant remains a puzzle. Imagine a game of chess where you know all the rules, but you cannot see the pieces. That is how many scientists feel today. They know there is something there, but they cannot clearly identify it. One of the most intriguing questions that arises is, why does this constant seem to have such a perfect value? If it were a little different, the universe could be a completely different place. It might have collapsed in on itself or expanded so rapidly that galaxies would never have had time to form. Is it possible that there is a purpose behind this value? Some researchers suggest it could be related to the very nature of reality itself. But what if it is not just a constant? Some physicists have begun to explore the idea that there could be multiple constants interacting in complex ways. This raises a fascinating question. Could the cosmological constant be just a symptom of something larger, a phenomenon we have yet to identify? The cosmological constant is not only a topic of debate in science, but also invites us to reflect on our place in the universe. What does it mean for us as human beings to understand that there are invisible forces shaping the cosmos? It reminds us that despite our advancements, there is much we do not know, and that human curiosity is the spark that drives us to keep exploring. As theoretical physicists and astronomers work together, new questions arise. Could the cosmological constant be a clue about the future of the universe? Could it help us understand how everything will end? Some theories suggest that as the universe expands, dark energy could become even more dominant, leading to a future where galaxies drift so far apart that we will never see them again. Despite the challenges, the study of the cosmological constant and dark energy remains a vibrant field of research. Each discovery leads to new questions, and in our journey to understand the cosmos, it is essential to keep an open mind. With every answer we find, we realize that the universe is even more mysterious than we ever imagined. So as we gaze at the stars on a dark night, let us remember that the universe has secrets still waiting to be revealed. The cosmological constant is just one of the many unknowns that motivate us to keep questioning, exploring, and marveling at the vastness of the cosmos. What other mysteries does the universe hold for us in the future? Only time will tell. The idea that our universe might not be the only one raises a series of questions that, rather than providing answers, seem to open doors to countless possibilities. What if other universes existed, each with its own physical laws, realities, and perhaps even forms of life? The notion of the multiverse has captured the imagination of scientists and dreamers alike, suggesting that reality could be much more complex than we believe. Imagine a vast ocean of universes, each like a bubble floating in an endless sea. Some of these universes might be almost identical to ours, while others could be completely different. What would a universe where the laws of physics are different look like? Would there be forms of life that we couldn't even recognize? This idea is both intriguing and perplexing. One of the foundations of the multiverse concept comes from quantum mechanics, where particles can exist in multiple states at the same time. What if those same rules applied to entire universes? In this context, every choice we make could create a branching in reality, giving rise to a new universe where a different decision was made. Which universe would you choose to visit if you could? String theory, which seeks to unify the fundamental forces of nature, also suggests the existence of additional dimensions. These dimensions, invisible to us, could harbor completely distinct universes. Can you imagine a universe where time does not flow in the same way as in ours? Or perhaps one where gravity does not exist at all? The possibilities are fascinating and often difficult to comprehend. Moreover, some scientists have proposed that our universe could be just one of many bubbles in an inflationary multiverse. In this theory, the universe would expand so rapidly that some regions would become isolated, forming independent universes. What secrets might be hidden in those distant universes that we could never reach? As we delve deeper into the idea of the multiverse, questions arise about the nature of existence itself. If there are infinite universes, does that mean that every possible story has already occurred? Could we find a universe where dinosaurs never went extinct or where humanity never existed? The notion that every decision, every event could give rise to a separate universe is simply astounding. However, not everyone is convinced that the multiverse is a valid theory. Some critics argue that there is no way to prove the existence of other universes, making them more speculation than science. But what if science itself is limited by our current understanding? What if the multiverse is just one of many ideas that challenge our conventional thinking? Despite these doubts, the concept of the multiverse continues to inspire both scientists and artists. In literature and film, we have seen representations of parallel realities and journeys between universes, fueling our collective curiosity. Who hasn't dreamed of crossing a portal to a place where the rules are different and anything is possible? On the other hand, the multiverse also raises profound philosophical questions. If there are infinite universes, what does that mean for our identity and our understanding of what is real? How would this affect our decisions and our morality? The idea that our actions could have an impact on multiple realities can be both liberating and overwhelming. As we continue to explore the cosmos and unravel its secrets, the possibility of the multiverse reminds us that there is much more to discover. Each new advance in physics and cosmology could bring us closer to understanding our place in this vast landscape of realities. What new mysteries will be revealed as we advance in our knowledge? A particularly intriguing aspect of the multiverse is how it could influence our understanding of time. If there are universes where time is a completely different concept, could we learn from them? Could we find answers to questions about the nature of time itself that have puzzled philosophers for centuries? As we delve into these questions, it is important to remember that the multiverse is not just an abstract concept, but an invitation to imagine the unimaginable. It challenges us to question our beliefs and expand our understanding of the universe. Human curiosity is insatiable, and the desire to explore the unknown is what drives us to keep seeking answers. In the end, the idea of the multiverse leads us to reflect on our place in the cosmos. If we are just a bubble in a vast ocean of universes, what does that mean for our existence? Are we alone in our search for meaning, or are there others like us in parallel realities? Exploring the multiverse is not only a journey through space, but also a journey within ourselves. It invites us to question, to reflect, and to dream. With each discovery, we come a little closer to understanding not only the universe we live in, but also ourselves. The search for answers may take us to unexpected places, and the multiverse could be just the beginning of an endless adventure. What are cosmic rays? This question may seem simple, but it actually takes us on a fascinating journey through space. Imagine you are on Earth, surrounded by a blanket of air that filters most of the radiation bombarding us from the cosmos. However, there is a special class of particles that manage to penetrate this protective shield, cosmic rays. But where do they come from, and why are they so important? Cosmic rays are subatomic particles that travel at nearly the speed of light. Most of them are protons, but we also find electrons and atomic nuclei of heavier elements. The intriguing thing is that despite their name, these rays are not actually rays in the conventional sense. They are more like particles moving through space, and when they collide with the Earth's atmosphere, they generate a shower of other particles that can be detected on the surface of our planet. Have you ever wondered why they are so enigmatic? The answer lies in their origin. Although numerous studies have been conducted, we still do not know for certain where most of these cosmic rays come from. Some scientists believe they are generated in supernova explosions, while others suggest they could originate from active galactic nuclei. However, the truth is that many of them remain a mystery. One of the most fascinating features of cosmic rays is their energy. Some of them possess energies that are millions of times higher than what we can achieve in particle accelerators on Earth. Imagine what that means. These particles have been traveling through space for millions of years before they finally collide with our atmosphere. How is it possible that they have acquired so much energy on their journey? When a cosmic ray enters the atmosphere, a spectacular phenomenon occurs. When it collides with air molecules, new particles and radiation are generated, creating what we know as a particle shower. This process is not only fascinating from a scientific point of view, but it is also key to understanding how the universe works. What stories could a cosmic ray tell if it could speak? Cosmic rays also have an impact on our daily lives, although we may not always notice it. They have been shown to affect electronic devices and satellites in space. In fact, astronauts who spend extended periods in space are exposed to higher levels of cosmic radiation, raising questions about the safety of long-term missions. Are we really prepared to send humans to Mars considering exposure to these rays? Furthermore, cosmic rays play a crucial role in scientific research. Cosmic ray detectors are distributed around the world and allow scientists to study their composition and behavior. This data not only helps us understand the cosmos, but also gives us clues about the nature of dark matter and dark energy, two of the greatest mysteries of the universe. What secrets could they reveal about the structure of the cosmos? The study of cosmic rays also helps us understand extreme astrophysical phenomena. For example, when we observe a gamma-ray burst, one of the most energetic events in the universe, we may be witnessing the result of a cosmic ray interacting with other elements in space. Each new discovery related to cosmic rays brings us a little closer to unraveling the secrets of the universe. In the search for answers, scientists have developed theories about how cosmic rays might be connected to other mysteries of the universe, such as dark matter. Some theorists suggest that cosmic rays could be a clue to understanding the nature of this strange substance that makes up most of the universe but that we cannot see. Could there be a connection between these seemingly disparate phenomena? Cosmic rays have also taught us about the time and history of the universe. By studying the arrival of these particles, scientists can gain information about events that occurred billions of years ago. Each cosmic ray is like a time traveler, bringing with it tales of what happened in the cosmos long before our species existed. What stories from the past are they telling us? At the end of the day, the existence of cosmic rays reminds us of how vast and mysterious the universe is. It invites us to keep exploring, questioning, and seeking answers. Each new discovery about these particles brings us a little closer to understanding the secrets hidden in the depths of space. Are we ready to unravel those mysteries? So the next time you look up at the starry sky, remember that there is more than meets the eye. Every star, every galaxy, and every cosmic ray is part of a much larger narrative, one that we are just beginning to understand. The cosmos is full of surprises, and cosmic rays are just one of the many pieces of this intricate puzzle. What new secrets will scientists uncover in their quest to understand the universe, and what other mysteries await us on the horizon? What is the ultimate fate of the cosmos? This is one of those questions that has fascinated scientists and philosophers since time immemorial. As you look out into the vast universe, you may wonder, will it continue to expand forever? Will it ever stop, or will it collapse into a great void? The theories about the fate of the universe are as varied as they are intriguing, but each one raises profound questions about the nature of existence itself. First, envision an expanding universe. Since the moment of the Big Bang, approximately 13,800 million years ago, the universe has been growing, pushing galaxies farther apart. But what will happen when it reaches its limit? Some scientists suggest that it could continue expanding indefinitely, stretching and stretching until the galaxies become so distant that they are no longer visible. Can you imagine a universe where eventually nothing is observable, a cold, empty space where loneliness reigns supreme? However, there is another theory that posits the universe may be destined for collapse. Imagine that after eons of expansion, gravity becomes so powerful that it begins to pull everything toward a central point. This phenomenon is known as the Big Crunch. In this vision, the universe would contract, crushing itself. What would happen at that moment? The laws of physics as we know them might cease to apply, leading to a dramatic and mysterious end. Would it be a new form of rebirth or simply the absolute end? As we consider these possibilities, another intriguing question arises. Could the universe reach a state of equilibrium? Some scientists theorize about the Big Freeze, where continuous expansion leads to an increasingly cold and empty, yet stable universe. In this scenario, stars extinguish one by one, leaving a vast ocean of darkness. Is this the most solitary fate imaginable, a universe that cools and slowly fades away? Another option is the Big Rip, a scenario in which dark energy, that mysterious force accelerating the expansion of the universe, could cause the acceleration to increase to extreme levels. In this case, galaxies, stars, and even atoms would be torn apart in a catastrophic process. Is it possible that in the distant future, the universe becomes a chaos where everything disintegrates? As we explore these theories, we cannot help but wonder which of them is the most likely. The truth is that, so far, there is no consensus among scientists. Each theory has its supporters and detractors, and each is based on different interpretations of observational evidence. What does this mean for us, the inhabitants of this small blue planet? Perhaps the uncertainty is part of the appeal. It reminds us that despite our advancements, there is much we still do not know. Advances in technology and astronomy are beginning to offer clues. Observations of distant galaxies and cosmic background radiation present us with fragments of the puzzle. But the complete picture remains elusive. Could it be that deep down the universe has a cosmic sense of humor, playing with our curiosity and expectations? The mysteries of the universe lead us to reflect on our own place within it. If the cosmos has an end, what does that mean for our lives, our stories? Should we worry about the fate of the universe or, on the contrary, embrace what we have while we can? The search for answers is what drives and unites us, leading us to look up at the sky and question what we see. On this path of searching and discovery, sometimes the questions are more important than the answers. Each theory about the fate of the universe opens the door to new inquiries. Is there life in other corners of the cosmos asking the same questions? Are there conscious beings in other galaxies also looking toward the stars, questioning the same fate as we do? Human curiosity is a powerful engine. It drives us to explore, to investigate, and to challenge the unknown. As astronomers and physicists continue their work, each new discovery brings us a little closer to unraveling the secrets of the cosmos. What revelations await us in the future? What new theories will emerge as we advance in our understanding of the universe? Ultimately, the fate of the cosmos is a reflection of our own existence. It reminds us that, although our lives are fleeting, the universe has a story that extends beyond what we can imagine. It is a reminder that, even though we may not have all the answers, the search itself is a valuable and meaningful journey. So, as we look up at the sky, let us remember that each star we see is a testament to the grandeur of the universe and our eternal curiosity to understand it. What connects regions of the universe that seem distant and independent from each other? The horizon paradox leads us to reflect on a fascinating phenomenon, the homogeneity of the cosmos. In such a vast universe, why do certain areas appear to have similar characteristics, as if they share a secret? Despite being separated by colossal distances, some regions of space exhibit similar temperatures and characteristics, challenging our understanding of how the universe has developed. Imagine a vast starry ocean where each star is an island. How is it possible that these islands so far apart maintain a similar climate? To understand this, we must delve into the concept of the cosmic horizon, a boundary that marks the maximum distance from which light has had time to reach us since the Big Bang. But what if I told you that beyond this boundary, there are regions of the universe that we have not been able to observe and that could reveal more surprises? This phenomenon raises an intriguing question. If the universe has an average background temperature, why do regions that have not been in contact seem to be tuned? It's as if two people who have never met speak the same language without having learned it. The answer lies in the expansion of the universe. In its early moments, after the Big Bang, the cosmos was extremely hot and dense. Light and matter could move freely, communicating with each other. However, as the universe expanded, it cooled, creating a limit that has left some areas disconnected. But here comes another mystery. What if I told you that despite this disconnection, the universe has a kind of memory that manifests in the uniformity of its temperature? This memory is the result of interactions in the past, where regions of space shared information before the cosmic horizon was established. However, how is it possible that similarities still exist despite the separation? Scientists have proposed that cosmic inflation, a period of accelerated expansion that occurred just after the Big Bang, could be the key. This phenomenon may have allowed areas of the universe that today seem distant to once have been in contact, thus distributing energy and temperature uniformly. But why is it so difficult to test this theory? The answer lies in the very nature of the cosmos, which still holds secrets that could change our understanding. Some might wonder, are these regions really connected in some way, or do they just seem similar by chance? The horizon paradox not only tests physics, but also our intuition about how the universe works. Could it be possible that there are still undiscovered forces or particles acting across these vast distances? Human curiosity drives us to explore, to question, but in this case the answer is not so simple. Many scientists are working hard to unravel this mystery using telescopes and advanced technology. However, the deeper we delve, the more questions arise. Could we one day observe beyond the cosmic horizon? What mysteries lie there waiting to be discovered? Moreover, the horizon paradox invites us to reflect on our own existence. If the universe is so vast and mysterious, what place do we occupy in it? Are we really alone in our quest for answers? In the end, every question that arises only leads to more questions, and that is how science progresses. The search for truth is an endless journey, where each discovery reveals a new horizon of possibilities. On this journey, the horizon paradox reminds us that the universe is a place of wonders and surprises. It teaches us that, although we may feel disconnected from our surroundings, there is an invisible network that connects everything. Perhaps deep down, we are all more interconnected than we think, even in such a vast cosmos. Therefore, as we continue to explore, let us not lose sight of the beauty of the unknown. Every mystery that is revealed is an opportunity to learn more about our place in the universe. The horizon paradox is just one of the many questions that lead us to seek answers, and perhaps at the end of this journey, we will discover that the true mystery is not just the cosmos, but our own curiosity and desire to understand it. So, as we gaze at the starry sky, let us remember that each bright point may be a beacon of knowledge waiting to be reached. The horizon paradox teaches us that, although there is much we do not know, the search for truth is what truly unites us in this vastness. And in the end, it is that search that makes our journey through the universe so extraordinary. Have you ever looked up at the night sky and wondered what lies beyond the stars that shine before your eyes? In the vast universe, there are phenomena so extraordinary that they challenge our understanding. One of these mysteries is quasars, which are like cosmic beacons in the darkness of space. But what exactly are quasars and why are they so fascinating? Quasars are extremely bright galactic nuclei powered by supermassive black holes. But how is it possible for something so distant to be so luminous? The answer lies in the enormous amount of energy released when matter is drawn in by the intense gravity of a black hole. As this matter approaches, it forms an accretion disk that spins at incredible speeds, generating heat and light that can surpass that of thousands of galaxies combined. And what about their distance? Many quasars are located billions of light years away from us. This means that when we see them, we are looking back in time to eras when the universe was very different. So what do these quasars tell us about the history of the cosmos? They provide us with a window into the early moments of galaxy formation, helping us understand how matter organized itself in the universe. However, despite their brightness, quasars remain an enigma. While we know they are the result of supermassive black holes, there are still many unanswered questions. Why are some quasars brighter than others? What conditions are necessary for a black hole to become a quasar? These questions keep astronomers in a constant search for answers. An intriguing aspect of quasars is their variability. Sometimes their brightness can change in a matter of days or weeks. How is it possible for something so distant and massive to change so quickly? This phenomenon suggests that the matter surrounding the black hole is in constant motion, creating patterns of light that challenge our expectations about the stability of the universe. Quasars are also useful for measuring distances in the cosmos. By studying their light, scientists can determine how far away they are and, in doing so, gain a better understanding of the expansion of the universe. But what happens if a quasar is located in a region of space where there aren't many galaxies? How can we know if its light has traveled through a vacuum or has been influenced by the gravity of other objects along the way? As telescopes become more powerful, we are discovering more quasars than previously thought possible. Some of these quasars are so far away that their light has taken over 10 billion years to reach us. This raises another fascinating question. What aspects of the primitive universe can we understand through these distant beacons? While quasars are bright objects, they also serve as a reminder of how little we know about the universe. Each discovery about them generates new questions. What other surprises does the cosmos hold for us? Perhaps there are quasars we have yet to discover, or related phenomena that challenge our ideas of physics. Another related mystery is the behavior of quasars in relation to their environment. They are often found in dense regions of galaxies, but not always. Why do some quasars appear to be alone while others are surrounded by galactic bustle? This variability could offer clues about galaxy evolution and black hole formation. And let's not forget that quasars may also be home to exoplanets. Imagine a planet orbiting a supermassive black hole. How would that affect life, if it exists? The extreme conditions around these objects could be both a blessing and a curse for any form of life trying to thrive. As we explore more about quasars, we also face philosophical questions. If the universe is so vast and full of mysteries, what is our place in it? Are we destined to be mere observers of an undefined cosmos, or is there a greater purpose in our quest for knowledge? Ultimately, quasars remind us that the universe is a place full of wonders and surprises. Every time we observe one of these phenomena, we get a little closer to understanding the complexity of the cosmos. But as we unravel the secrets of quasars, we also realize that each answer generates new questions. The journey toward knowledge is endless, and ultimately, it is this pursuit that defines us as humanity. So the next time you look up at the starry sky, remember that in the vastness of the universe, quasars shine like beacons of mystery. They invite us to keep exploring, to question the unknown, and to marvel at the greatness of the cosmos that surrounds us. What really happened at the moment our universe began to exist? This is an enigma that has fascinated scientists and philosophers throughout history. The origin of the Big Bang, that initial explosion that gave life to everything we know, remains a topic of intense debate and speculation. But what does Big Bang really mean? Was it an explosion in space, or rather an expansion of space itself? When we talk about the Big Bang, we often imagine a loud and bright explosion. However, in reality, it was not an explosion in the conventional sense. At that moment, there was no space to explode into because space itself was emerging. In an instant, the entire known universe was compressed into an incredibly dense and hot point. But before that, what was there? Did anything exist? Or did time and space begin to exist with the Big Bang? Scientists have proposed various theories about what might have occurred before that primordial explosion. Some suggest the existence of a prior state of the universe where the laws of physics as we know them did not apply. Other theories venture into the concept of cycles of expansion and contraction, where the universe may have gone through multiple Big Bangs over time. The question persists, could we ever know the truth about what happened before the Big Bang? As the universe expanded, the first subatomic particles began to form, which would later group together to form atoms. But how is it possible that from such a small point, everything we see today emerged? Energy turned into matter, and in a relatively short span of time, the first stars and galaxies formed. But how do we know that this sequence of events is correct? Could there not be other explanations? The evidence for the Big Bang comes from various sources. One of the most intriguing is the cosmic microwave background radiation, an echo of the primordial heat that can still be detected in the universe today. This discovery not only supports the Big Bang theory but also raises new questions. What does this radiation tell us about the state of the universe in its early moments? And what else could we learn from this ancient remnant? However, the mystery does not end there. As scientists delve deeper into the nature of the Big Bang, concepts emerge that challenge our understanding. For example, cosmic inflation is a theory that suggests the universe underwent an extremely rapid expansion in its early moments. But what caused this inflation, and why did it stop? Each answer leads to new questions and more mysteries. The Big Bang also raises philosophical questions. If the universe has a beginning, does that mean it has an end? Are we doomed to live in a universe that will expand forever, or is there a possibility that it will eventually contract? These questions compel us to reflect on our place in the cosmos and the ultimate fate of everything we know. Moreover, the concept of the Big Bang lies at the intersection of physics and cosmology, making it a fascinating topic for those who wish to explore the limits of human knowledge. Could there be other universes with their own Big Bangs? And how would those universes interact with each other? The idea of a multiverse, suggesting that our universe is just one of many, adds an additional layer of complexity. The quest for answers about the origin of the universe drives us to continue investigating and exploring. With each discovery, we get a little closer to understanding how it all began, but at the same time, we face more questions than ever. Are we prepared to confront the possibility that some of these questions may never be answered? Or is that the true essence of human curiosity? The exploration of the origin of the Big Bang is an endless journey where each answer leads us to new horizons. Technological advancements and new scientific theories continue to challenge our notions of time, space, and existence itself. Who knows what revelations await us in the future? So, as we look to the stars and try to unravel the mysteries of the universe, let us remember that every question we ask is one step closer to understanding. The origin of the Big Bang is just one of the many enigmas that invite us to explore, question, and above all, marvel at the vastness of the unknown. The adventure of discovering the truth about our universe has only just begun, and each of us has a role to play in this endless quest. Black holes are one of the most impressive and enigmatic phenomena in the universe. What exactly are they? They are regions of space where gravity is so intense that nothing, not even light, can escape their pull. But how do these mysterious entities form? Imagine a massive star that, upon exhausting its fuel, collapses under its own gravity. This collapse can lead to a black hole, a point where matter is concentrated in an infinitely small space. But what happens inside? At the heart of a black hole lies what we know as the singularity. This is the place where the laws of physics as we understand them cease to function. It is an absolute mystery. As at the singularity, density becomes infinite and the curvature of space-time becomes extreme. But how can we know anything about something we cannot observe directly? The answer lies in the effect that black holes have on their surroundings. Black holes are not solitary entities. They are often surrounded by material that is being drawn toward them, creating an accretion disk. This disk is made up of gas and dust that spin at high speeds. And as they approach the black hole, they heat up and emit radiation in the form of X-rays. Can you imagine what it must be like to see a black hole devouring matter around it? Although we cannot see the black hole itself, we can detect this radiation, which gives us clues about its existence, but not all black holes are the same. There are three main types: stellar black holes, which form from collapsed stars; supermassive black holes, which are found at the center of most galaxies and can have millions or even billions of times the mass of the Sun; and intermediate black holes, which are less understood and could be the link between the first two types. How is it possible that some black holes are so enormous? The question of the origin of supermassive black holes is a real puzzle. Some scientists suggest that they formed from the merging of smaller black holes, while others believe they could have formed from enormous clouds of gas that collapsed in the early moments after the Big Bang. But what does this mean for our understanding of the universe? The presence of these giants at the center of galaxies could influence the formation and evolution of the galaxies themselves. Black holes also have a fascinating effect on time. Due to their intense gravity, time dilates as one approaches a black hole. For a distant observer, time would seem to slow down as an object approaches the event horizon. The point of no return. Can you imagine what it would be like to experience time so differently? This curiosity leads us to wonder if we could one day use black holes as a kind of time machine. However, black holes are not just sources of scientific curiosity. They also present philosophical and theoretical dilemmas. What would happen if someone fell into a black hole? Could that person survive? Most scientists agree that once you cross the event horizon, there is no turning back. The fate is inevitable, but the theories about what could happen inside a black hole are fascinating. Some suggest that you could be stretched by tidal forces, a process known as spaghettification. And while black holes are known for their veracity, there is an even more surprising aspect. Black holes can evaporate. This phenomenon, proposed by physicist Stephen Hawking, suggests that black holes can emit radiation, known as Hawking radiation, which means that over time they could lose mass and eventually disappear. What would this imply for our understanding of the universe? It is curious to think that despite being so dark and mysterious, black holes are also fundamental to the structure of the cosmos. Many supermassive black holes have been found to be related to the formation of stars and galaxies. How is it possible that these cosmic monsters influence the creation of new worlds? The answer may lie in the energy they release by attracting matter, which could trigger the formation of new stars in their vicinity. Black holes are also a bridge to understanding quantum physics. The way they behave within the framework of general relativity and quantum mechanics raises questions about the nature of space and time. Could there be a way to reconcile these two seemingly opposing theories? This is one of the great challenges of modern physics. In summary, black holes are more than just simple gravitational traps. They are bearers of secrets about the nature of the universe. They push us to question what we know about gravity, time, and matter. As we continue to explore these mysteries, we not only expand our understanding of the cosmos, but also delve into the depths of our own existence. What other secrets does the universe hold for us? The search for answers continues, and black holes will remain one of the most fascinating enigmas we attempt to unravel. What is really hidden in the void of space? At first glance, we might think that the void is just that, a space with nothing in it. But what if I told you that this void is full of mysteries that challenge our notions of reality? The idea of the quantum vacuum is a fascinating concept that leads us to question the very nature of the universe. Imagine a space that seems completely deserted, yet at a microscopic level, particles are constantly emerging and disappearing. How can that be possible? This is the essence of the quantum vacuum, a phenomenon that suggests that the void is not simply the absence of matter, but a dynamic field full of infinite possibilities. But how can we understand something that seems so contradictory? Quantum mechanics, the branch of physics that studies subatomic particles, tells us that particles can exist in multiple states at the same time. This principle raises an intriguing question. If the quantum vacuum is full of particles that appear and disappear, what does that mean for our understanding of space and time? Could it be that the void itself is alive in some way? In this context, the idea of vacuum energy emerges. What is this energy and how does it influence the universe? It has been proposed that this energy is responsible for phenomena such as the accelerated expansion of the universe. But how can something so ethereal have a tangible impact on the reality we know? This mystery leads us to delve into the connection between quantum physics and cosmology. Quantum vacuum fluctuations may seem like something out of a science fiction novel, but they have real implications. For example, it has been suggested that these fluctuations could be related to the creation of particles in the primitive universe. Could it be that the quantum vacuum played a crucial role in the birth of the cosmos? This question leads us to explore how particles form and ultimately how everything we see around us comes into being. As we delve into this mystery, we also encounter the idea of wormholes. These are theoretical tunnels in space-time that could connect different parts of the universe. Could the quantum vacuum be the key to understanding how these wormholes work? If the void is full of activity, perhaps it holds the answers we seek about the connectivity of the cosmos. However, not everything is straightforward in the quantum world. As we venture into this strange realm, we encounter the paradox of observation. When we try to measure or observe something in the quantum vacuum, what we find may not be what we expected. Why? Because the act of observation can change the behavior of the particle. This raises a profound question. How can we trust what we see if observation itself alters reality? And this is where the concept of quantum entanglement comes into play. What does it mean for two particles to be connected in such a way that the action of one affects the other, regardless of the distance separating them? This phenomenon suggests that the quantum vacuum is not just an uninhabited space, but an interconnected fabric that binds everything that exists. Are we talking about a universe that is more united than we think? As we explore more about the quantum vacuum, we encounter the possibility that the universe is filled with hidden dimensions. What lies beyond our 3 spatial dimensions and 1 temporal dimension? Some scientists suggest that there could be additional dimensions that we cannot perceive. Could the quantum vacuum be the gateway to those unknown dimensions? But there's more. The quantum vacuum also raises questions about the creation and destruction of matter. If particles can appear and disappear, is it possible that the universe itself is in a state of constant creation and destruction? What implications would this have for our understanding of time and existence? In this context, the idea of quantum gravity emerges as an attempt to unify quantum mechanics with general relativity. Could it be that the quantum vacuum holds the keys to solving one of the greatest enigmas of physics? The search for a theory that unites these two forces has led many to explore the vacuum as a fundamental field of study. Finally, we cannot overlook the philosophical impact that the quantum vacuum has on our understanding of reality. If the void can be a place of constant creation, what does this say about the nature of existence itself? Are we in some way connected to a vast field of possibilities that transcend our current understanding? The exploration of the quantum vacuum not only leads us to question what we think we know about the universe, but also invites us to reflect on our own nature and our place in the cosmos. As we continue to probe these mysteries, let us remember that every answer we find may open the door to new questions. And so, the cycle of knowledge renews itself, driving us to keep exploring the unknown. As we delve into the mysteries of the universe, it is fascinating to think about what we have discovered and what still remains to be explored. Human curiosity is insatiable, and every enigma that arises only leaves us with more questions. What secrets does the vast cosmos hold? Throughout our journey, we have touched on aspects that seem straight out of a science fiction novel, yet they are realities that challenge our understanding. Looking up at the starry sky, it is easy to feel small and insignificant, but what lies behind those twinkling lights? Galaxies, planets, and stars are just the surface of an ocean of mysteries waiting to be solved. Could it be that we are alone in this immense universe? Or are there other forms of life waiting to be discovered? The search for answers motivates us to keep exploring, to not give up in the face of the vast unknown. Dark energy, for example, is a concept that challenges us to rethink our understanding of physics. How is it possible that an invisible force is accelerating the expansion of the universe? Science has only just begun to unravel this enigma, and each advance brings us a little closer to the truth. However, the question persists. Will we be able to truly understand what this dark energy means for the future of the cosmos? Wormholes present another dimension of fascination. These hypothetical tunnels in space-time lead us to imagine the possibility of traveling between galaxies in an instant. But do they really exist? Could we one day cross one of these cosmic bridges? Each theory that arises opens up a range of possibilities, leaving the mystery of what we might find on the other side hanging in the air. In the vast emptiness of space, there are nearly deserted regions, such as the cold void of Bootes. Why does such an empty place exist in a universe that is mostly filled with galaxies? Nature has a peculiar way of organizing itself, and each discovery in these empty spaces leads us to question how the structures of the cosmos form and evolve. The geometry of the universe is another one of those enigmatic questions. Is the cosmos flat, curved, or does it have an unexpected shape? The shape of the universe could determine its ultimate fate and what awaits us in the future. Curiosity pushes us to wonder if we will ever be able to visualize the true shape of everything around us. And then there are pulsars, those neutron stars that spin at astonishing speeds, emitting radiation like beacons in the dark. What secrets do they reveal about the life and death of stars? Each pulsar is a reminder of how extraordinary the cosmic cycle can be. And their study offers us clues about the nature of time and space. Dark matter, which has become a true puzzle for scientists, represents a significant part of the universe and yet remains hidden from our senses. How is it possible that something we cannot see has such influence on galaxies? The search for dark matter leads us to reflect on all that we do not know and to open new doors toward understanding the cosmos. And in the end, what about time? The arrow of time poses deep philosophical questions. Why do we feel that time moves in one direction? The flow of time is a shared experience, but its nature remains a mystery. In a universe where everything is in constant change, understanding this phenomenon could radically alter our perception of existence. At the heart of a black hole lies the singularity, where the laws of physics as we know them cease to exist. How can a place in space contain such force that even light cannot escape? This concept challenges our understanding and invites us to imagine what might happen in those unexplored territories. The cosmological constant is another enigma that has baffled scientists. Why is this number so crucial for understanding the expansion of the universe? The search for answers leads us to explore the very nature of reality. And each discovery brings us one step closer to the truth that underlies the cosmos. The concept of the multiverse also intrigues us, posing the possibility that infinite parallel universes exist. What would that mean for our understanding of life and existence? The idea that we might be just one of many realities leads us to question our own uniqueness and what it truly means to be human. Cosmic rays, those high-energy particles that come from deep space, remind us that we still have much to learn about the origins of the universe. Where do they really come from, and what are they trying to tell us? The search for their origin could provide answers to questions we have only just begun to formulate. Finally, as we contemplate the fate of the cosmos, we face uncertainty. Will the universe expand forever, collapse in on itself, or freeze in darkness? The possibilities are as varied as they are intriguing. The exploration of the universe is an endless journey. and every answer we find leads us to new questions. As we close this chapter on the mysteries of the universe, it is evident that every solved enigma is just the beginning of another. Curiosity drives us to keep inquiring, to challenge the limits of our knowledge, and to seek answers that ultimately bring us closer to understanding our place in the vast cosmos. The adventure has only just begun, and the universe awaits us, full of secrets to discover.